This for Dr. Wagner and Mr. McGinnis. And we'll start with you, Mr. McGinnis. We'll give Dr. Wagner a chance to wet his whistle. What is your specific role and planned approach to implementing my Bill S-97, the Nuclear Energy Innovation Capabilities Act?
Thank you very much. First, let me say, obviously, we stand ready to fully implement the law once it is and at the point at which time the President signs it. But I can tell you that many of the activities that we are doing at the Department of Energy is certainly very much in line with the provisions. We greatly appreciate the leadership and support, the acknowledgement of the importance of a fast spectrum test reactor, of which we do not have in this country, and just a couple have them around the world. And it is a great disadvantage for us, and it will absolutely inhibit us from being able to support this new bow wave of highly innovative nuclear reactor designs coming into the pipeline in the United States. Certainly, also Idaho National Lab and the other national labs that we leverage effectively to support nuclear energy in the mission, they are well positioned to support the approach for a national test center for reactors, and also to work even closer with the Nuclear Regulatory Commission and the other key provisions.
Yeah, thank you for that. And Dr. Wagner, I want to come back to you. You actually said a couple things in your remarks that kind of address this. You said we want to continue to maintain leadership, and of course that would be this would be a critical area, maintaining leadership around the world. And I have to compliment, you said you're calling it ModSim 2020, which to kind of reverse engineer a phrase, instead of hindsight being 2020, this is going to be foresight is 2020. So,
I like that.
No, so I appreciate that. So what is going to be your specific role in implementing this bill?
So we have significant roles in implementing this bill, along with the federal staff in the Department of Energy, Office of Nuclear Energy. Actually, we've made tremendous progress already relative to the versatile test reactor. Let me kind of make some comments on that, if time permit. As I mentioned, the need for the versatile test reactor has been well defined. There's several different reports and industry statements about the need. So we've been moving forward even in parallel with this legislation. So with the relevant stakeholders, we've developed the functional requirements for the VTR. The mission need document, what we refer to in DOE 413 language as Critical Decision 0, is being prepared now and will be submitted in January of 2019. Last week, $3.5 million in university awards were announced to address the various technical aspects of the VTR. Earlier this month, we selected several initial university proposals to participate in the VTR program, with an emphasis on experimental designs, and we're negotiating the terms of those contracts now. In the near future, INL will award a contract to an industry partner to complete the conceptual design and cost estimate for the VTR. The current schedule calls for a completed conceptual design and cost schedule estimate as input to what they call Critical Decision 1, or CD1, to be completed in 2021. So, and as I mentioned, the plan is for the reactor to be operational in 2026. I can go on further. We have plans for the Nuclear Reactor Innovation Center, as well as ModSim 2020, if you'd like more details on those.
Well, I appreciate that, and certainly we will look to those going forward, but I'm about to run out of time. I want to get to Mr. Bowers real quick to see how your company, if you at all, do you think that the implementation of NECA will affect X Energy and its partnership with DO National Labs? I wanted you to weigh in on that, please.
Partnership with national labs, the example that I had cited in regards to development of fuel, it's important to recognize that at least 15 years, if not 20 years, of research and development was performed at both Idaho National Lab and at Oak Ridge National Lab in regards to this particular fuel form. And this fuel form is referred to as TRISO. We talked about that before, and specifically uranium oxycarbide. It's not manufactured anywhere else in the world. It is unique to the U.S., and it provides a capability within the fuel to generate more power than our competitors in China or from other countries could. So branching off from that understanding, from that capability, taking what those PhDs at Oak Ridge National Lab have learned and be able to translate that into the marketplace is key. So our goal is, as we build our commercial fabrication facility, and at the moment we are looking at Oak Ridge, Tennessee as the potential location for that facility. It's strategic to locate the fabrication facility there because we would have not instant, but very easy access to those PhDs as we're developing our commercial processes. If we have problems, issues that arise, we need some additional research to be performed to be able to go right back into the labs and use that capability.
So I'm over a little bit over my time, so suffice it to say your company is well positioned to make that transition.
We are poised and ready and funded by the Department of Energy to make that happen.
Well, that's good to hear. Mr. McGinnis, I want to jump to you real quick with the committee's indulgence. You cited challenging market conditions and the availability of innovative technology as reasons as to why the nuclear energy sector is currently undergoing a transformative period. With that in mind, does it make sense for DOE to continue to provide substantial financial backing to any nuclear project that isn't A, scalable, B, cost-effective, or C, flexible? Is that going to be a hard corner to turn? What do you think?
Thank you very much. That's a very important point. First of all, I do want to qualify that there continues to be a very important role for large-scale nuclear reactors. In fact, the United States Department of Energy, thanks to the congressional leadership support, we have what is considered the most advanced, commercially available, large, passively safe set of reactors available in the world, and that is with Westinghouse's AP1000 and the ESBWR. That was hard-fought, strong technical partnership over the years with the U.S. We're proud to have supported that. Those reactors remain available. 4 have now just been completed in China, the AP1000. We're looking to the 2 in Vogtle to get done. Those provide 60 and 80
You and
years.
a whole lot of people. Keep
Yes,
going.
yes, sir. But the fact is they do play very important roles. However, as I indicated, I believe that there is a far greater percentage of market out there, customers that want nuclear, clean, baseload nuclear, but these products, large and large, are just too large. They need product choice. They need to be able to go in and not bet the farm with the company's balance sheet. And so that's why we think that this is going to open up an entirely new market and give customers finally the option to access nuclear without the choice of betting the farm and waiting 5, 10 years to see any revenue generation.
Yeah, well, thank you for that. That was our hope. Thank you. And I apologize to the committee for being over time. Mr. Tonko, you